The operating microscope is one of the most vital pieces of equipment in microsurgical operating room, and particularly in neurosurgical one. Modern counterweight balanced microscope can be navigated in all required planes of movements with the help of surgeon's hands. In order to overcome the necessity of manual control over the microscope and to facilitate microsurgical manipulations, we propose the MARI device, which provides hands-free positioning of the operating microscope and adjustment of its optic system. This device is designed for the navigation of the counterweight balanced microscope and consists of the rigid titanium part with supportive plates. A locking mechanism, a joystick, and an electric switch located within the chin of the supportive plate. A special fixative frame is easily attached to the binocular tube of the microscope. The device is fixed to the frame with a single screw. Multi-channel cable provides a connection between the microscope and the device. The fixative frame located on the binocular tube does not cause any inconvenience for surgeon who operates without the device. An electric heating system, which prevents fogging on the surface of the eyepieces, is attached to the binoculars. The electric switch in the chin supported plate of the device provides the release signal for the magnetic clutches of the microscope. When the switch is pressed, the pushing mechanism on the hand grip is activated, leading to the release of all joints of the microscope. To begin the microsurgical manipulations, the surgeon takes the required position in relation to the microscope and by pressing the joystick with his or her lips, locks the device. To navigate the microscope in the desired direction, the surgeon slightly opens his or her mouth and moves his or her chin forward. Opening the mouth and chin movement leads to tight connection of the surgeon's head with the device due to the increased distance between the parieto-occipital and chin regions, and pressing the electrical switch provides the release of all magnetic joints of the microscope. Now the surgeon can navigate the microscope with little effort in all directions, including not only transitional movements along XYZ axes, but also rotational ones, which gives an advantage over the mouth switch device for microscope navigation. The surgeon, by closing his or her mouth, simultaneously releases the electrical switch of the device and locks magnetic clutches of the microscope. This is how the microscope is navigated by the surgeon. By pressing the joystick, the surgeon can unlock the device and release his or her head. The device permits hands-free control over the microscope's optic system. The multifunctional joystick provides not only closing and opening of the device, but also adjustment of focus and zoom. Slight motions of the surgeon's lips to the right, to the left, upwards and downwards provide the transmission of the corresponding signal, focus up, focus down, zoom in and zoom out to the microscope control system. The MARI device provides very precise movements of the microscope and lets the surgeon to manipulate without taking his or her hands out of the operating field. This is a demonstration of the virtual surgical procedure, where the surgeon tries to build a column with small features. Supported plate in the nose bridge area provides static position of the surgeon's eyes relative to the binoculars, so that the permanent view of the operative field is sustained during the microscope movement. Advantage of the MARI device is obvious. It is clear that without MARI device, all these manipulations would have been much more complicated. The device is attached to the sterile microscope without any difficulties. All parts, including fixative frames, cables, heating system except metallic holder, are located under the sterile drape. The cable with an electric plug is pulled out of the sterile drape through a small opening near the binoculars and connected to the device. The MARI device provides easy and accurate navigation of the operation microscope in great range of movements around the operative field. The optic parameters can be adjusted quickly when changing the position of the microscope. It is important to note that the surgeon's head is not compressed when the microscope is kept in static position. The surgeon feels only a mild contact with the supporting plates, which causes no discomfort. This video represents the course of surgical removal of the left optic nerve hemangioblastoma without using any rigid retractors. The surgeon frequently changes his position around the craniotomy side in order to use all available exposure without disrupting surgical procedure. The MARI device significantly facilitates microsurgical manipulations. The optic parameters can be adjusted easily and quickly when changing the position of the microscope. The device allows the surgeon to perform surgical manipulations through the deep and narrow operative corridor without using brain retractors. MARI device allows to increase the accuracy of the surgical manipulations and to shorten the duration of the surgery. When needed, by pressing the joystick, the surgeon can unlock the device and release his or her head. The inventor of the device has applied it in about 600 operations ranging in difficulty and with duration up to 7 hours. It is possible to adjust the MARI device to all types of the counterweight balanced microscopes. The device can be useful in all fields of surgery where operating microscope is required. The device is packed in a small suitcase and can be easily transported.